Bro, Miller, you're really interested in manufacturing? My name's Mark. I do VRC, I've done third year VRC. Yeah, feeding up next VRC. Soon to compete in next FRC. Some point not next FRC. Alright, so it's either...
And I think we can do pretty well, but right now this is pretty much the only set we got. So you can see right here we have this patch went up to space. We did a lot of parts for SpaceX, thousands and thousands of parts we did for them. These were parts we did for SpaceX, these ISO grids right here. You'll see a lot of these parts represented in like our Aerospace Academy. It comes from machining parts like this for SpaceX. So you can see they took that patch up and they gave us a nice letter. We were really a pivotal kind of supplier, manufacturer for that Falcon 9 project, and so we really were, like I said, we did a lot of work for them. So that was kind of an honor for us, right? So. There's fifth axis they're coming out with. Is there a fifth axis?
The U5 is.
The U5, yeah. And what's that price point on that U5?
I think it's around 90.
I thought 90-ish, so under 100K is kind of the idea. So they're definitely trying to come in all from level price for good quality machines.
And we should be getting one around a little after the first of the year.
Okay. Yeah. Make a lot of room to fit all these new sizes in here, man.
I think October we're getting a 5, 7, a 9, and a L2 or
okay.
L3.
Yeah.
So you said sending me an X7.
Yeah.
Already. No, it's
They're one of the best parts that we can take as well. I'm not a fan of trunnion tables. I know they're necessary, especially like if you're trying to upgrade.
It's cool.
On an integrated 5-axis like this, it's so much better than a trunnion. Because the accuracy. So trunnions, same as 4th-axis rotors, they get backlash. But that's not really what 5-axis really is in industry, It's made to be basically a glorified indexer, which rotate, machine this, rotate, machine this, And that's what you want it to be because it's more accurate, it's more rigid doing it that way. Of course you can, do the full simultaneous movements if you want, but I always teach people to only do that when you absolutely have to. But that's basically what a 5-axis is for, is to take what would be 6 operations down to 2 operations. So, actually I was hoping this would be done. Oh yeah, so it's about to be done. I could actually show you a little movement. So I still got it set up from a class that I did last week on this subject. And so I machined this little square block, which is basically this. So we machine it with the bottom of the tool and then the side of the tool. And then we rotate it, same thing, bottom of the tool and then the side of the tool. And we do that all the way around. And the theory is if your center of rotation is perfect, then this should blend perfectly on all sides. So this is a very good test block that I've implemented at every company I've worked at to make sure that your machine is accurate. Because if not, you'll never make an accurate part. So I use that as an example to show like, okay, how do we program this thing? Like the thing.
Hello. This place is pretty cool, but we've been stuck on this one machine for a little bit. So, we're moving now. Let me record.
Obviously, on like the cylindrical side and everywhere else, you would grind something to go off and dress it and then come back in with a sharp wheel. But what's up, and I will go over there, it has an overhead dresser. So as it's actually in the cut, the dresser is dressing itself and it comps for the wheel and the part. So this is done in one pass at 1 inch a minute, and it just ate it. The wheel looked brand new. I don't have the wheel over here.
How much are wheels?
So these aluminum oxide wheels, they're like $200-300. So they're not too bad. These diamond ones are like a tool grinder. There's a tool. So that's a diamond wheel. It's a cup wheel for clearances. That's probably $1,000-1,200 or something like that. But they'll last a good amount of time before you have to replace them. These aluminum oxide wheels, they break down. They're not too bad.
How many times can you get like redressing it?
You can get quite a bit. So whenever you run out of clearance is a big issue. Machines have what's called thermal stabilization. So I'm not sure if like mills have it, they might have it, but grinding machines, they'll have the coolant flowing around the base the entire time because everything has got to be climate controlled. So like, I mean, when you're holding 2 tenths consistently with a stone, grinding machine is very accurate. So, and then that's,
I mean, that's kind of one of the reasons to use it, right? I mean, you're talking about super flat, super round,
yeah,
super straight.
So like all of the gauges, like those 1, 2, 3 blocks, y'all probably are familiar with those.
Those got to be.
Those are ground and probably lapped in.
Yeah.
So I mean,
What's the weirdest material y'all had to machine here?
here.
Weirdest.
I don't know.
What about weirdest? I mean, we've had some hard materials and stuff like that, you know, like I say, a lot of your Inconels are tough and stuff like that. Haynes 188 is real tough because it's mainly cobalt, you know, cobalt's nasty stuff. You know, it had 14% tungsten in it, you know, so.
Yeah. Go get a piece of ceramic and put it on the lathe. See how hard it'll be to grind it. But, or carbide. Get a piece of carbide, put it on the lathe. You can't do that. I mean, you probably could with like a diamond tool.
Yeah, it'd be a long, painful process.
Yeah, but these diamond tools over here, you just wipe out carbide. Like I can make an end mill in like 4 or 5 minutes. So
Y'all make y'all's own end mills in house?
so we're partnered with Kennametal. So I do a lot of custom tools like the Jade end mill. It's right here next to your
No,
mud.
right there.
Oh, that's Jade. Oh,
Don't drop it.
So I saw this. What would you like primarily?
Yeah, please don't drop it. I only got one of them left. Barry broke the other one.
Here, Walker can't have this.
Neither can I.
Here, you can go another.
Yeah, so since they're diamond,
That is crazy.
glass. So I made one out of glass, and that's the one Barry broke, so you can actually see the stone in it. And I got the idea from like diamond saws, like they do style work with diamond saws.
Jade. Be
So I
careful.
have a diamond mill.
yeah.
I can grind stone.
Took us a while to find that jade,
So we did a
actually.
piece of glass.
Yeah,
Barry
to
just
find the
shattered
actual
it. Glass
diameter.
was too thin and too brittle.
Grind.
But I did the research and I found out that jade was actually 3 times tougher than ceramic, and we use ceramic in mills. Now it's not harder, it's just tougher. And the jade end mill actually cut wood.
Say cut wood, right?
Yeah, it cut wood, derrelin, and it made about that far in aluminum before Barry broke it. That's the word of the day. Barry broke it.
Barry
broke
broke
it.
it. That's right.
But, yeah.
That's about right. So this is kind of where we store a lot of our tools. That's a balancer. So we got a balancer there. We got a preset there. Yeah, we got a shrink fit like that.
What's up, guys?
I think some of you guys might know this guy.
What's up, man? Welcome. What do you guys think about the shop? We haven't got yet. Oh, right on. Oh, he's got the camera out. Look at that. What's up, man? What's up, man? Howdy. How are you?
Good to see you. Good to see you.
Awesome.
Did he skip you?
Did I get everybody? Awesome. What do you guys think about the shop?
Pretty cool.
It's crazy.
You haven't seen Barry crash the machine yet? That's the best part of the tour.
We're told
Yeah,
it happens frequently.
I know.
Yeah, we said that's the quote of the day. Barry broke it.
Exactly.
Quote of the year.
Very cool.
Quote of the year.
A lot of cool. We got guys focused on rocketry, additive, engineering. So really kind of at the pinnacle of where manufacturing technology is going. It's kind of cool. So.
You guys all saw like your shirts? I slaved last night. I was trying to go home, and then they were like, "Oh, you guys are coming." So I'm over there signing all those shirts for you guys. All good.
Yep, they brought us some shirts too.
Huh?
They brought us some shirts
awesome,
too.
man.
Yep.
How far away is the school?
We're in
Hour?
Oh,
Like a-
our
yeah.
I thought it meant the school year. I was like, we're in it right now.
Yeah. No. We're good. Awesome.
Like an
man.
hour.
Well, welcome. And how's he taking care of you?
Oh, yeah. Great.
He's doing all
He's doing
right.
really good. Amazing.
Yeah. Cool.
Yep. for
Awesome,
sure.
man.
All right,
Well, nice
appreciate
seeing you guys.
Thank you.
All right, guys. All right, so this, so it's funny. So we used to only have half the shop, right? So we only had this, and actually you can see right here, this line right here is where there was a wall right here. And so we got to this point where we had that side of the shop, and we really needed to make a decision on whether we were going to take this half or somebody else was going to take this half. And so bulldozed the wall and we took this half. EDM at your school, guys. This is Trevor. He's our EDM manager, guru, whatnot, stuff like that. So.
How many of you guys have seen a wire EDM before?
Not in person.
No, but
I've heard of it, not seen it.
So much people
the
do.
videos and stuff. Yeah. So this is a wire EDM, and honestly, the biggest difference between any of those machines is it doesn't use a cutting tool. It uses electricity to actually erode the material. Because of that, we can cut materials with virtually any hardness. It doesn't care about hardness. So you can do carbide, polycrystalline diamond, all that kind of stuff. All it cares about is if the material is conductive. So as long as it's conductive, it'll actually work in the wire. Another benefit too is like it doesn't actually, it might look like it's touching the workpiece, but it never touches the workpiece. So the wire isn't contacting the workpiece, and because of that, we can do super intricate and cool shapes like this flexure. So we actually machined this, and while we were machining it, it was in a flexible state. And since the wire's not putting tool pressure on the part, it can do that in a precise way. So super unique machine. Typically when none of the other machines can accomplish the features that the engineer has set out to accomplish, it comes to the EDM department. But one limitation of the machine is it's got to go all the way through the part. So you can't do any blind features on the wire. Another super cool thing is the upper and lower head. So the wire is actually traveling through a guide in the upper head, and then on the bottom, which you can't see, there's a lower head that also has a guide in it, and that's keeping the position of the wire. It's super, super accurate. So if you focus your attention right here, you'll see what looks like a solid block, but it's actually not. That is 2 pieces. So I can, yeah. We'll wipe all that dirt off of there. So that is 2 pieces right there. And what's cool is this actually will trap air. So like, you know, you push down on it and it kind of goes down, but if you move it over there, it drops. It's super, super precise.
I've seen videos where they have like the shaft and the machine, and they sit there and they push it down and flick.
Yeah. What'd you guys design it in?
Fusion 360.
Okay. I've actually never played with their generative, you know, module, but I've heard it's like really good.
It's really intuitive.
Yeah.
Oh yeah.
So if you guys ever get a chance, I highly recommend Topology. Topology is like, it's so powerful. It's incredible.
So immersive. Back a quarter turn. Go back a quarter turn. No idea how much easier you're making this. I'm 35. Getting up and down kind of sucks. All right, what about that? Do the smallest turn possible back the other way. One more of those.
Yeah, exactly. Once you're there, you just touch it.
I mean the tiniest turn possible. The same way? Same way.
I don't know if that was the tiniest turn possible, though.
All right, come check it. See what you think.
Well, it is because there's a little bit of flex in my tool.
Yeah, good.
Crush that in a vise and
Ingenuity.
smash my hammer into my wrench into it.
See what you think about that.
Well, thank you for your help. You have no idea how much faster and easier that is.
Yeah, thought it's awesome.
Super cool.
So much of
Stuff's pretty cool, right?
Is this a new machine?
Yeah, this one just came in. Yeah, came in a couple days ago.
That's
This
awesome.
is the Tornos XT. I think, yeah, XT32.
That's awesome.
They all start out as this: 12-foot long, 1/8 diameter bars. Here's some titanium we have for a bone screw we're doing next.
That's insane.
But yeah, that's what it starts out as, and just makes one after another. All these machines work like this, and once the bar gets to the end, it brings it back. This little clamping device here will grab the end of the bar. It'll drop a small remnant in here, index that, feed a new bar in. It runs without people.
That's so insane.
Yeah, these machines are nice for that reason. Once you get them set, you're kind of done. They're one of the few things that exist that's fully automated from the get-go. Like once I align that and I get the bar feeder in here and I string that up, every single part that I run in that machine will work like this. Out of 12-foot bars, shrinking them down, making part after part. When it's done, it loads a new bar. So it's kind of the rewarding version of machining.
Insane.
Yeah, a lot does go into it.
Have you seen the titanium part? Have y'all seen the titanium heart? They're doing titanium heart.
You don't have to. This thing just rotates. And
Can we touch
I know. I was trying to make it.
Forget 908. It blows up.
I think some of this was the generative design.
Yeah,
This is
so-
a generative, this is a generative.
I was wondering, what are these parts? They look very like familiar. I think I've seen some.
Well, we did a video on them and stuff like that.
Yeah, this looks
I
like.
believe this is generative.
This looks like one of those meshes, like whenever people have.
It's a
like-
skull mesh.
Yeah, that's what I was just thinking. Yeah.
Yes, sir. Yep. Yeah,
See how
Trevor did
3D
a good
print
video on that.
Yeah,
people's
these look like
skulls?
those. So there was a thing AI did. They did like a study with AI, and they made it design a rocket engine, and these look very similar to.
And I'm pretty sure you'd have to ask Trevor, but I think that was kind of the idea. There's a
Yeah.
couple fuel induction systems or
Yeah,
something like
it
that.
looks very
you know, so.
similar. Yeah.